Welcome to the Rational Optimist podcast. Today's guest is Peter Webb, a Green Beret commander, one of a few commanders of a Special Operations Robotics Detachment, and the Director of Mission Operations at Allen Control Systems. Allen Control Systems is a defense technology company leading the development of autonomous counter-drone weapons. Before joining ACS, Peter led counter-drone operations at Anduril Industries.
Peter, I'm curious, what is the most important thing you learned from working with Brian Schimpf?
I got to meet Brian a few times in the DC office, and getting to sit down with him at a personal level, you got to see how good of an engineer he was. So he's someone who, at a fundamental principle, like understands, hey, this is how my object, my widget, whatever we're developing, here's how the thing works. But he, like the rest of the Anduril founding team, also understood this thing doesn't work outside of a larger operational context. So how am I going to use this thing? So I think the Anduril founding team, which is actually very similar to what we have with Luke and Steve and Mike at ACS, is like you have guys who are very competent and unbelievable engineers, but they put faith and confidence and they surround themselves with the people who know how this thing is going to be implemented. And so that's the way that we tested and developed a lot of assets over the last 4 years at Anduril. Was we understood that, hey, here's a nascent piece of technology. I need to take this outside of the sterile environments that you get in at typical military training sites, put it into where I know it's going to be a contested region, but that's where my object is going to learn the best. And so that's where we're going to have the right people doing the right thing and back them up with the engineers who know the tech the best. But so getting to see how Brian and the rest of that founding team sort of approached not just the air defense products, but the products overall at Anduril. I mean, they're all focused on, hey, this is solving a particular pain point, and we know that this engineering piece is solid, but we need the people who are going to be employing this thing as well to sort of bring it together as one cohesive thing that's really going to make a difference.
So, Pete, everyone knows by now that drones are defining the Ukraine war. What's something that most people don't understand yet about how drones are reshaping war in general?
I think that there's a lot that goes on every day that changes in terms of how drone warfare works. I think the rate of change is what people don't necessarily understand, that they see drones and they say, okay, well, that's how warfare is going today. Well, drones are just there to accomplish like an actual tactical military task. Like they're going out to do something. It's not just employ robotics and you get a victory on the other side. You have to have people who understand the breadth of what robotics is. And so on our military side, we look at it not just from, hey, are you good at employing this thing? Like you have to understand how it's built, how it's going to operate in the spectrum that you're going to be needed to operate in. How do I employ this thing without giving away my signature or essentially putting myself at too much risk? But also understanding that what I did in order to employ a robot, a drone, whatever it may be, a week ago, 2 weeks ago, may not work tomorrow. Because there's people on both sides that are continuously innovating because their life literally depends on it. And so they have to say, all right, well, the Ukrainians did X tactic. Well, how can we counter that? So there's a lot of back and forth in terms of that chess match of, hey, my asset went out and it had success, but now I need to change that. And so that's where you saw the maturation of essentially drones going from really like C2 linked, so command and control link, with a GPS guided assets doing sort of high hover dropping ordnance to now there have been so many advancements there and changes within the battlefield that they're putting electronic warfare assets in. They put up nets, they put up a lot of different things to deter those. Now they're going wire guided, low flying, fast moving FPVs that are able to maneuver through wood lines and get past some of those threats as well. So I think people just need to understand that the rate of change is constant, and sometimes it's not necessarily a leap forward; it's a regression of, hey, you're so far indexed on the way that this works. Well, I'm going to regress to a previous tactic that worked maybe 12 months, a year ago to see if that works. And so it's a lot of trial and error.
You mentioned drone deterrence, and of course, there's many different systems and options for that. But tell us what you're working on at Allen Control Systems with the Bullfrog system.
Yeah. So at Allen Control Systems, I always tell people that we're trying to solve the hard problem of how do you get freedom of maneuver back on the battlefield. So when I look at it fundamentally is that drones are stopping infantry units, army units, anybody from being able to go out and conduct traditional military operations in the way that like we have been trained to do for the last 30, 50 years. What we're doing at Allen Control is trying to solve the hard problem of how do I employ a product, an asset that does not need GPS, that does not put out signals, because both of those things can be my enemy in that type of region, but it also is able to defeat the threat that is that low-flying, fast-moving, wire-guided FPV that's not putting out an EW signal. It's going to be able to fly low enough to get underneath the radar, and they'll fly in a obfuscated manner in order to reduce the amount of time that you can get a camera on that thing. So what we've built, really what Luke and Steve and the engineering team have built is a robotic turret that is able to very quickly and very accurately point a traditional weapon system, being a M240 Bravo, which is one of the most common machine guns that you'll see in the battlefield, and be able to take that and now enable that traditional direct fire weapon system to now look up and identify threats in the sky, but be able to move so fast and accurately. So by being able to move essentially 400 degrees in a second with about 0.3 degrees of accuracy, we can identify that threat. So if something comes over last cover to concealed position and is about 500 meters or into 100 meters away from me, I'll have maybe 5 to 20 seconds of total response time. So our system has to be able to identify that, put a barrel on it, and be able to, with a user in the loop, say, engage all within a 3 to 5 second time frame in order to provide that last final protective fire. And if you provide that final protective fire, then you can re-enable a lot of the traditional military operations that are currently stagnant. I mean, we've watched countless Russian lines come against the Ukrainians and get rebuffed because they're able to go out. They will deter their mechanical approach with wire-guided drones. They'll be able to get inside the wheelbase into the turrets and stop those tanks in their tracks. And then once those guys dismount, then it's a bad day for the Russians. And so if you're able to create that final protective fire bubble, something that it does that close in defense, you really give the Ukrainians or whomever, like the U.S. in our instance as well, the ability to go conduct those traditional military ops with an asset like this.
We're still in the 1v1 era of drone warfare, but it seems like only a matter of time before you turn all those 10,000 strong drone light shows into drone autonomous swarms, right? Is the goal eventually to have hundreds or thousands of bullfrogs on any given battlefield to kind of counteract that?
Yeah, and so I mean, this sort of goes back to the way that we look at product. We have a good ops team on the ACS side, so we have a lot of guys who've been in the field. They understand what the different mechanisms of combat are going to be, whether you're infantry, armor, special operations. So we see it being pretty prolific across because drones are going to be down to every level of warfare. So I need to be able to have that kind of defense, that automated defense inside of my units all the way down to where they're going to need to be able to counter that. I think everyone... The progression is always going to be, well, what beats what? Like, there's always going to be the next iteration of, okay, well, I can now cycle between targets every 2 seconds. Well, now I just send out more targets. Okay, now I need to put out more bullfrogs. I think one of the things that we consistently look at with drone swarms, I mean, if you go out there during one of those light shows with a spectrum scanner, I mean, you'll be able to clearly identify what they're operating on. It is absolutely technically feasible to create a I would say more moderate swarm of assets that are running visual-based nav. They have frequency hopping radios. You could get a collection of pilots together in order to run a multiple wire guides. But now you're also putting out a bigger signature into the world. And so everything comes with a give and take on that.
You know, one of the wildest things about the system is that it has the ability to shoot down a DJI drone or really any drone from 200 yards away with just 2 bullets. Speak to what had all the different parts of the system that had to come together, the AI, the optics, the stabilization to make that level of precision possible.
Yeah, and I think the fundamental problem that Luke and team were able to solve was the electric motor control. And so being able, like when you have electric motors of that scale, being able to have input voltage and knowing exactly where this thing is going to be pointed at any point in time is intrinsically a hard piece to do. So we have about 30 different measurements that we consistently look at inside of the system that are giving us an update as to where this barrel is pointed, how much capacitance we have within the system, et cetera, to say, I know where I'm pointing, and at my next task, I'm going to move to exactly this point. And then once we have the threat in our field of view. Then we run a CV model. So we have EO and IR to identify the threats. We run complex backgrounds, so small object detection on complex backgrounds with EO and IR cameras in order to say, hey, here's this object. Then once we put a laser on it, a laser rangefinder, we can say, hey, here's exactly how far away it is. So now I don't need to broadcast radar. I don't need to broadcast all these other signals that would essentially inherently give me away. I can put out a low light source to say, here's how far away it is and here's how fast it's moving. Now I have the camera on it, so I know exactly what my elevation to that object is. And then internally, we can calculate the time of, all right, in 3 milliseconds, we know it's going to be here. The muzzle velocity of my 7.62 is this, so here's my point of intercept. And so when you see the system operate, it'll track, it'll pop to where it needs to fire, it'll put those rounds out, and then it'll go back to tracking. And so it'll actually do predictive analysis to say, here's how fast it's moving, here's where it's moving, this is the arc to which it's moving at, because like a straight-on drone, I mean, even pilots that are operating now understand that they can't fly straight at targets anymore. The Ukrainians and Russians are running around with frangible AK-47 rounds. They've got shotguns. They've got other things in order to do their own self-defense. So a lot of pilots will do corkscrews. They'll do like oblique angles. And so what we have our system training on is that low flying, fast moving threat that's moving up and away from you. So what's the hardest possible angle that I could put this thing into? And so make sure that predictive analysis is on target each time.
So there are a lot of different categories of anti-drone weapons under development. Right. You've got microwaves, lasers, drone-to-drone combat, electronic warfare. Why did you choose autonomous, robotic, anti-drone turrets to work on?
I mean, I think my wife always sort of laughs at like, how did you get into this job, Pete? Like, how did you show up here? I think the last 4 or 5 years, I mean, I did 10 years active in the military, moved over to the National Guard. The last 4 years at Anduril were extremely illuminating on the technology front. I got to be very hands-on with the engineers of understanding how radar systems work, understanding how optical CV models work, what kind of ML models are we putting into existence, and like, what are the capabilities, limitations of these things. And that's what spurred me getting into the drone warfare side of it as well for my military job. And so running that team now, like, all right, well, I know the capabilities, limitations of these systems. Well, how do I start countering these? How do I use my experience as a counter drone operator to make myself and the rest of my guys the best drone operators that they could possibly be? And when I looked at it, like, every system has its function. Like, we always talk about a layered defense. And so we talk about how do I do detect, track, ID on these large drones that are out there or aircraft. How do I understand what's going on in my battle space with radar, with CV models, with EW systems? Like, everything has its capability and its limitation. So where when I looked at it, what can't you really counter when it comes to an FPV drone? An FPV drone simply does not have the capability to armor itself from a pure kinetic strike. So anything that I'm putting onto a target, like, it's just a small, like, usually carbon fiber board with a couple soldering points and a flight controller and some props. It's all relatively weak stuff. And so if it takes kinetic impact, I mean, I've dropped my FPV and broken a prop and had to go back and like take it apart and be pissed about it. So I can spend enough time fixing FPVs to know that if I hit it with something moving fast, it's going to fall out of the sky. Whereas like the other systems, I mean, lasers, directed energy, EW, each one of those has its place and its time of, hey, here's where it fits in the overarching echelon. But when I think of like what I wanted to solve was, what does that final protective fire look like when something is like inside 1,000 meters of me and I don't have the time to spool up any of those other systems. The capacitor hasn't charged. The spool up time on the rocket is just too slow. Once I found out that Allied Control Systems was looking for this kind of position, I was like, oh, that's absolutely an interesting way to solve this problem. And I mean, honestly, like, coming from an infantry background and a special operations background, like, the machine gun was always the central point to any military operations. And so now I can take what was inherently a dumb weapon system, I can put it into this amazing turret and make it a very versatile combat system. Like, we look at it primarily from a counter drone perspective these days because everybody's worried about drones. But there's a lot you can do with a smart turret that's outside of the bounds of counter UAS. Like, now I can take a weapon system that typically has like a 3 MOA, reduce that maybe to about a 1 MOA, minute of angle for the accuracy of the weapon system. And then I can be very accurate with direct fire. I can plug it into networks. And so now I can shoot at things that I haven't seen before. So you get into the actual application of machine gun theory. Machine gun theory was a really fun concept that I was taught back when I was an infantry officer, but like it's hard to employ because you don't necessarily, you have to have a forward observer, but now you have thousands of forward observers that can do that kind of identification. So yeah, when I learned about Allen Control and found out what they were working on, like I thought, one, I love the machine gun and think that this is a great advancement for it. And two, just being able to put all my knowledge together from what I learned at Anduril, what I had done for the military. Well, this asset will actually provide like the final protective fire that soldiers need in order to actually save lives.
What's your best guess as to how far away autonomous drone swarms are?
Oh God. I mean, it all comes down to the person and the people that they have around them. Like a good engineering team, like you can do most of these things today, in my mind. Like if you have the right engineering team and the right components and the right military necessity to do it, I'm sure someone could put together a drone swarm. Now, is it a repeatable, sustainable thing? That's a whole nother story. Is that like we tend to look at defense assets of, hey, I've built something. Now I need to sustain it in perpetuity because it's an asset. Drone warfare in Ukraine particularly has not been that. It is, hey, I tried this, it worked. All right, great. Well, tomorrow it didn't work, so I'm going to try something new. It's using the same components, it's being able to put those components together in different ways, to leverage open source models, to leverage like simple things like Raspberry Pis. Like how do I put that like edge compute device into a small flying object to give me that additional advantage over my enemy of, hey, now it's doing a compute where I don't have to do that compute. So it's surfacing a decision to me, and that decision I can now make.
You mentioned the rapid iteration that's happening on the battlefield in Ukraine, and you have software updates happening multiple times a day, dozens of times a week, versus, these big exquisite systems that we're used to updating every, couple of years. How do you make systems future-proof, given that things are developing on a week-to-week basis?
And I think future-proof is probably a bit of a misnomer. I mean, things are continuously changing. So, like, in order to make it future-proof, I have to be able to change it at the rate of change. And so, like, we focus a lot at Anduril and at ACS is how am I controlling my software and what software am I pushing at the right time? Because, I mean, anyone who's run one of these defense tech organizations, like, how many branches of software do you have in GitHub and like who's merging and everything that needs to go into maintaining that primary software branch, but also being able to understand that, well, what works in OIR may not be the right branch for Africa, may not be the right branch for Eastern Europe. I need to be able to tailor it to the environment that I'm in. So I think future-proof is not necessarily like I set something once and I'm done with it. It's more of I need to have that flexibility built into it. And I mean, even like all your legacy primes and everybody else is sort of identifying that, well, software has to move faster. Like how often do I update my iPhone? I don't know, whatever it tells me. So I update that and I'm good to go. But like the impetus for change is going to be more consistent, particularly on your larger systems, which we're never going to get away from. And you have to have that larger scale defense in depth from a geopolitical strategic perspective of, hey, this object deters like these larger Russian, Chinese, whatever objects. And so that boils all the way down to the tactical level of, all right, well, how do I now stop a small FPV from coming and disrupting my multi-million-dollar asset? Well, now I need to put that into the battlefield as well. So
just a quick follow-up on that. So something like the Bullfrog is actually, you can do over-the-air software updates?
Yes. So we've always been able to push over-the-air software. And so it's one of those things where with the appropriate testing, like I'm always comfortable pushing software. Never will I push a software update that hasn't been tested rigorously in the field. So it comes down to those organizations being able to have that codified process of we've made these changes, we've validated them, we've updated software. And now, like, whatever my validation process looks like, it has to have at least an update in a controlled environment before I push that to a uncontrolled environment.
Do you see a world where Bullfrog is used outside of the military in civilian applications? Like, for example, we know that cheap drones, any bad guy can get a cheap drone and like attack a stadium, for example. Do you see them stationed outside of stadiums, maybe?
I think when you start looking at home defense, like within the continental U.S., you get limited by a couple things. Like one being FAA, so I'm not able to do as many EW systems like that I would like to be able to do. But there are ways to modify Bullfrog, primarily when you look at the munition that we can use. So we can use polymer rounds, so just like plastic-based rounds. You can use frangible rounds, which are essentially just like hard-packed metal rounds that once they impact something, they'll disintegrate. But it'll still put enough kinetic energy into a small, essentially under 250 gram drone that I'll break something, I'll disrupt it, and if I don't break it on that round, I'll hit it again. The primary reason that people are hesitant of putting Bullfrog in the U.S. would be because it is a gun. And so, well, when I shoot a gun and the round misses, where does that round go? So if we're able to absolve that problem, and now I can essentially do stadium defense, I can do more protection around the Capitol, whatever it may be. There's ways to work around it, but it's like there's that layered approach again. Like this isn't the one thing that will do it all. There has to be those other systems in place as well. Like, can something do a controlled takeover of that that incursion drone without having to fire a shot and land it in a safe place? Or are they running a frequency hop? Or are they running an unknown protocol to where we can't do that, and now I have to go down to like a physical defeat?
Are you seeing a shift inside the military from focusing on procuring big, expensive systems to smaller, more affordable, more nimble ones?
I think it is you're never going to get away from the large systems. I need to have tanks and I need to have airplanes. Like the ability for us from a strategic capability to have like the 82nd Airborne, 100 for the 1st Armored Division, that capability that it provides our country is always going to be necessary. There's now additional investment in what does a unit common asset look like? What do I need to give guys in order for them to be successful on the battlefield? And if you're not thinking drones, if you're not thinking robotics, like then you're going to be behind the curve. So yeah, there's definitely investment into what soldiers are going to be using. I mean, my unit got several hundred FPV drones in order to train and develop on. And so like we are actively implementing those. We're changing our tactics, because by putting that tactics and technology together, we can develop new strategy to where now if I'm going to whichever region, because SOCOM is deployed to a lot of them at any point in time, like I can help manage my strategic objectives there by like leveraging the new technology into it. So I don't think we're going to get away from it, but you'll just definitely see a blending of, well, every asset now needs to be able to have that sensing capability. It needs to be able to do some sort of defeat. I mean, you'll see counter UAS as a requirement in a lot of these solicitations coming out of the military.
Is there a specific technology or tool that you wish you had had when you were in the Special Forces that's available today?
I mean, I think perfectly honestly, like during the global war on terror, it was a very different fight from what we see in Eastern Europe today. GWAT was a different kind of enemy. It was a different kind of construct where we owned the skies, we owned the spectrum, we owned like all the intangibles around getting on the objective. Now you're still going against very capable people who were able to do a lot of things that were creative with what they had, but the creativity was also limited by their lack of access to technology. So the increased access to technology basically at every level right now. So I mean, if you look at any terrorist organization around the world, I mean, they are learning from Eastern Europe. They're going on YouTube. They're getting assets from getfpv.com. Like they're able to identify like, hey, these are the things that I need to use in order to have an asymmetric effect on this large organization that is the United States. Was there anything that was available now that I wish I would have had? I mean, yeah, I would have liked to have better ISO. I would have loved to have a drone in my hand so I can go look directly where I wanted to at any point in time instead of having to guide a MQ-9 with a JTAC to go look at something. But really, I mean, everything that's been coming out in the last few years just shortens that timeline for decision analysis. When I was in theater a lot over the last 4 years, I talked to the different commanders about this, is that it's not so much that the decisions are changing, they're just coming up faster. And so if you look at the assets that you have, they have to be able to surface those detections, those capabilities that say, hey, this is something that's going on around you. Do you want to take X action on it? Yes or no? Because a guy sitting in a guard tower who's looking out into the wilderness, who possibly identifies a drone, then he gets on the radio, calls back, they try to orient everything on it. That's outside of their engagement timeline. We usually gave guys maybe 120 seconds of overarching reaction time. Whereas in global war and terror, like in Afghanistan or in other places, we owned all of the assets in the air. We owned everything around us. And so our decision timeline was a little bit longer. So
do you feel like the US military and the DoD has fully internalized the changes that are happening in Ukraine and therefore, will probably shape the future of warfare?
Oh, we're definitely making changes in the right direction. I mean, you'll see on every source of media that we're not moving fast enough. We're not doing X fast enough. It's always, what is the impetus for change? It's very similar to that 2003, 2004 timeframe when IEDs were becoming very big in Iraq. The way that those came up, proliferated from Iraq to Afghanistan, and then that rapidly changed the hardware that we were using, going from Humvees to MRAPs, and then changing your tactics and everything and your approach around that. It's a very similar environment to that, except you're not seeing U.S. service members die right now. And so, Ukraine has to have that high level of innovation because their life depends on it. Whereas we understand that is where everything is going. And so we're taking a methodical approach to it versus hey, this needs to change on a daily basis. And we're trying to make it a sustainable, repeatable, more essentially ingrained part of our training for everything that we do, particularly on the special operations side. Because with special operations, I mean, everything that I try to do is inherently going to be on that asymmetric side. Green Berets are traditionally going into countries to work with governments, either on the insurgency, counterinsurgency side, and how do you analyze everything there? How do I make my small team of 12 go work with another unit to execute larger objectives that 12 people normally could not do?
Well, we're getting pretty close to the end of our time. Before we go, we're going to do a rapid fire round of overrated, underrated, or properly rated. So Stephen will name a cutting edge military technology. You tell us your take and why.
This is my friend Tyler Cowan's favorite game, so I love doing it with everyone. Okay, ready to start, P?
Send it.
Swarms.
Moderately rated. I think it is one of those things that more often than not is going to be overcome by EW. So you haven't seen it in practical use for a reason.
Subsea drones.
They are appropriately rated. I think being able to work subsea and understand what's going on in that entire domain, which I have very little experience on, but when I start talking to my submariner friends, it makes a big difference.
Space weapons.
I think I have very little context in that, and I understand the space environment is very congested, and there are a lot of assets up there that are not ours, and we need to be able to get further ahead in that.
Electronic warfare.
That is definitely a appropriately hyped piece. Everything that we do these days is different from GWOT. You need to understand what the EW spectrum is and how to use it in your favor.
The Golden Dome.
The Golden Dome, I would say on par is one of those, everything needs to have that layered defense, and that being able to codify that layered defense in a way that provides actual capability is going to be important.
High energy lasers.
It's just I think those are appropriately hyped. I think it is a math problem in terms of once somebody figures out how to get the right focus at the right distance, then they will be consistently burning things out of the sky.
Hypersonic missiles.
Those are possibly a little bit underrated in my opinion, because they're moving so fast that it's hard to do any kind of intercept. So you need to develop very one critical infrastructure in order to detect them, as well as good tactical say procedures in order to stop them.
Last one on the list: augmented reality headsets like IVAS and stuff like that.
I've actually gone back and forth in terms of like where I think augmented reality fits. I think when you start looking at the three-dimensional scope of what warfare looks like today and the amount of sensors that are out there in order to service those decisions, you're going to need something that needs to that is able to present all that to you in a meaningful way. And so I think it's probably slightly under hyped right now, but will be a considerable part of the battlefield moving in the future.
Peter, I'm glad there are guys like you at startups like Allen Control Systems figuring out these problems. We'll send our viewers to Allen Control Systems' website to learn more about Bullfrog. Is there anything else you want to say, Peter?
No, I think that's a great interview. I appreciate the time, and yeah, I'm always happy to answer questions on this. I mean, obviously, it's a topic that's near and dear to my heart. Like my wife always likes to joke that I become the most popular person at the party because I just go around and depress everybody about how different warfare is, but I try not to frame it in that. I try to take your approach of like, hey, this isn't an overarchingly negative thing. We have a lot of really good, amazing people shifting the way that Silicon Valley, the way that the military is looking at defense tech. And so we're coming out with interesting, new, innovative technology in order to like deter and like counter a lot of these things, but also create a system where you're putting less lives at risk. So a lot more robot-on-robot engagements, but it's just you have to have a lot of really smart people out there to do it, and hopefully they still like to listen to guys like me who just have a lot of time on the ground.
I felt some rational optimism coming from you today, so thank you. Viewers, you can boost our optimism by hitting the subscribe button, ringing that bell, and leaving us a comment. This greatly helps our channel grow. We appreciate all of your support, and we'll see you next week.